Hello friends, welcome to the video lecture series of Engineering Mathematics 3. From last few lectures, we are discussing probability. In probability, we discuss probability distribution function, probability mass function, probability density function, random variable, continuous random variable, discrete random variables. Now, some typical probability distributions we are going to study. And these distributions are suitable for discrete random variable and some distributions are suitable for continuous random variable. Now, in this video lecture, we are going to discuss binomial probability distribution. In binomial distribution, probability of random variable is n combination R, in short NCR I am writing, small p to the power R and small q to the power n minus R. This is binomial distribution, where P is the probability of success in each trial and small q is the probability of not happening in a single trial. And it is very clear that P plus Q, probability of success and probability of failure, is 1. What is n? N number of trials here. N number of trials. R is the number of success you get in n trials. So we are going to start with very simple problem. Find the probability of getting 4 heads in 6 tosses of fair coin. How many tosses are there? 6. How many maximum heads you will be getting? 6. And how many tosses are there? Number of trials are 6. Here n is equal to 6. And out of these n trials, how many R you want? Means how many heads you want? We want 4 heads. Here R is equal to, therefore R is equal to 4. In binomial distribution, we want n, that is given, R, that is also there in the problem, and P is given. P is the probability of success in a single trial, that is also given. And once you get P, you can easily find out Q. Find the probability of getting 4 heads in a 6 tosses, in a 6 trial. In each trial, what is the probability of success? It is 1 by 2. Probability of getting head is what? It is 1 by 2. Therefore, Q is 1 minus P, means 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. Now, we want probability of getting 4 heads using this formula. N CR P to the power R and Q to the power n minus R. 6 minus 4. You can directly write 2. This is the first problem, therefore I am writing indirectly. Factorial 6, factorial 4, 6 minus 4 factorial, like this. But general formula I am writing, but I will recommend you to use calculator directly. The general formula I am writing, factorial n by R factorial n minus R factorial. But you can use this formula, you can get the value of 6C4. Meaning of 6C4, out of 6. In how many ways 4 you will get? That is 6C4, where the order is not important. But I will recommend you to use the calculator. You can take any calculator. NCR function is there. 6C4 I want. And 6C4 is what? 15. So I am writing directly here 15. 1 by 2 to the power 4 and 1 by 2 to the power 2. 2 raised to power 4 is 16. This is 1 by 4. Is 15 by 64. The 15 by 64 is the probability of getting 4 heads when we toss coin 6 times. 15 by 64 is 0.234. Now, second problem we are going to discuss. Question I am writing: if 10% of the bolts produced by the machine are defective. Okay, this information is available. Determine the probability that out of 10 bolts chosen at random. The first question is 1, second question is none, no one is defective, and third question is at most 2 bolts will be defective. If 10% of the bolts produced by a machine are defective, means machine is producing 100 bolts, the 10 bolts are defective. Machine producing 200 bolts and 10% of it, 20 bolts are defective, like this. Okay, this information is available. And out of those bolts, 10 bolts I have taken randomly. Out of those 10 bolts, no bolt is defective means 0 bolts are defective. Its probability we have to find. Third part of the question is what? Out of 10 bolts, at the most 2 bolts. At the most 2 bolts means what? 2 bolts or less than 2 bolts. 2 bolts, 1 bolt, 0 bolts like this are defective. Okay, this we want. So this is the question. Now, what is P here? Small p. What is the probability that the single bolt is 10% bolts are defective? Therefore, 0.1 is the probability that the bolt is defective. Q is 1 minus P. 1 minus 0.1 means 0.9. Out of 10 bolts means N is equal to 6 here. Out of 10 bolts, 1 bolt is defective, that we have to find. Out of 10 bolts, 0 bolt defective we have to find. Out of 10 bolts, 2 or less than 2 bolts are defective, that we have to find. Therefore, the R will vary here. R will be 1 here, R will be 0, R will be 2, 1 and 0. Now, what is the formula for this? Probability for x equal to R is NCR, small p to the power R and q to the power n minus R. P of R is n, 10 CR. P is what? 0.1 power R and 0.9 power n minus R. This is our equation 1. Now first one, the probability that single bolt is defective, that we have to find. Means R is equal to 1 here. P of 1 is equal to 10 C1, 0.1 to the power 1 and 0.9 to the power 10 minus 1 is 9, directly that. Now 10 C1 is 10, use calculation and get the value. 0.1, this multiplied by 0.9 power 9. It is 0.3874. Now, second question. Probability that none is defective. Probability that none is defective, put R equal to 0. 10 CR, R is 0. This equation 1 implies, put R equal to 0. 0.1 to the power 0. 0.9 to the power 10 minus 0 is 10 directly. And the answer to this 0.3474. Now, third one, probability that at the most 2 bolts will be defective. We want probability that at the most 2 bolts are defective, means in this way I will be writing at the most 2. Now R is less than or equal to 2. How to write? Probability that 2 bolts are defective, probability that or 1 bolt is defective, or probability that 0 bolt is defective. It means probability that at the most 2 bolts are defective in this value. And each of the events are mutually exclusive events. Probability of getting 2 bolts defective, probability of getting single bolt defective, probability of getting 0 bolt defective, all these are mutually exclusive events. Therefore, addition law of probability I use. Now, P of 1 is available. See, P of 1 is that we have already found. Therefore, I am writing value directly. P of 0 also we found 0.3474. Separately, P of 2 we are going to calculate. Where here I am going to calculate P of 2. P of 2 is required, and that I am going to find. P of 2 how do you get? See, put R equal to 2, 10 C2, P to the power 0.1 to the power 2 and 0.9 to the power 10 minus 2 is 8. P of 2 is 0.1937. P of 2 0.1937, and sum of this all this probability is equal to, it is 0.9298. 0.9298 is what? The probability that 2 or less than 2 bolts are defective. Okay, so just I am going to repeat it once again very quickly. The question is like this. There is a machine which produces bolts in huge amount, and out of this total production of single day production. Suppose randomly I picked 10 volts out of 1 lakh volts, out of 1 crore volts, or out of 1000 volts, whatever is the number. It is depend on the capacity of production of the machine. 10 volts are picked randomly, and out of these 10 volts I want probability of getting 1 volt defective, that we found. Second part of the question, find the probability that out of 10 volts 2 volts are defective, probability that 0 volts are defective, that we found. And the third sub question is find the probability that out of 10 volts at the most 2 volts are defective. At the most 2 means 2 volts are defective, or 1 volt is defective, or 0 volts are defective. That's why I have written P of R less than or equal to 2, and in this way I resolved P of 2 plus P of 1 plus P of 0. P of 0 is available, that I have written directly. P of 0 is also available, that I have written directly. If it is not available, that you have to find out at your own. And P of 2 is not available, so that I have found separately here by putting R equal to 2 here. And in this way, probability of getting at the most 2 volts defective, that I have calculated, which is 0.9298. So in this way, you can solve any problems of binomial distribution. We stop here. Thank you very much.